about smart grid for smart city. About smart grid, how we are implementing smart grid for a smart city. Normally, we know if we speak about city, we talk about the metropolitan cities. When we look the urban cities, if we take an example, Chennai, the total population of Tamil Nadu, if it is around 70 million, around 7 million of population, they are living in Chennai. If you take 1/10 of the population, they are living in Chennai. If you take another metropolitan cities in India, like if you take Kolkata, or if you take Bombay, or if you are taking Bangalore, the population in urban cities, they are very high. So why the people they are moving to the urban cities? No, the people they are moving to urban cities because the job opportunities, and they want to get a job. Economically, they want to get some benefits. That's the reason people they are moving from the village to the urban cities. And now, if you look, half of the population in the world they are living in urban cities, and an estimation says around 2050, 70% of the population they will live in urban cities. So, if you take urban people, the urban people population is very high, and the example they are consuming 75% of the electrical energy, and they are releasing around 80% of the carbon gases. So it is necessary to concentrate on the urban cities and to make the cities into a smart way. So that is called as a smart city. If you take a smart city, we are having three different stakeholders. If you take a smart city, or if you are taking a city, the city is having three types of people. One is public. We can say it is a stakeholders. Stakeholders, public, they are the major stakeholders in city. Then the government. Then we can business community. So there should be an interaction between all three. That way the city can work properly. If you take government, the government normally what they are doing is they are providing different say they are running a different sectors, like they are running transport, they are running hospitals, they are running education institutions. Okay, they are servicing to the people. The public, they are interacting with the business community for the jobs. They are purchasing items from the business community. So these three people they need to be together. Okay, so there should be a good interaction between these three groups. So if you look growth, already I told you around the urban population is projected to rise by 72% in 2050. So that is the reason we need to include ICT, information communication technologies. These information communication technologies, they can able to connect the resources to the people. If you look, what are the different resources? Already I told you, we are having the different resources like transport, energy sector, because energy like electricity that is supplied by the government to the public. Many of the countries all over the world, example, if you take an example, African countries, they are not allowing a private power producers, individual power producers. They are just allowing only the government to produce the electricity, and they are supplying the electricity to the public. Not only electricity, even the telecom sector, only the government is controlling the telecom sector also. But if you look the developed countries and the developing countries, they are having the individual power producers. Like I can generate electricity, I can supply it to the grid. And the next one is the healthcare. The hospitals. In many of the countries, they are just giving importance to the government hospitals. The developing countries already they have private and the public hospitals. Then water. So normally in countries we say utility it brings energy and water together, and then waste management. Not only these services, other than these services, the government providing other more services also. Okay, so they need to give accommodation to the people, like poor people, they should get an accommodation, proper accommodation or proper housing. That is another responsibility of the government. Additionally, the government having a different resources to supply the people. Now, the ICT is connecting these three stakeholders, and they are connecting transport, energy, healthcare, water, and waste management. About the smart city, The smart city, it can able to integrate all the services in an efficient way. It can create jobs, business, visitors. Like if it is a tourist place, it can able to attract the visitors because they can able to develop the tourist attraction informations and they can able to project it in the social media that can able to attract more visitors and better, healthier and safer place to live. Improving public services, transportation is much important. The road, the transportation, health is important, and then infrastructure improvement. These three, these all, when we give to the public can able to get a good social life, economic, and the environmental sustainability. I want to play a video. I don't know whether I can play the video or not. Can I play the video? Okay, I am just sending the slides to the organizer so you can able to get the slides, so you can play the video, you can able to understand what is a smart city. If we take the smart city, the smart city is having a different dimensions of element in a city. Like already I told you, the public services. So public safety is much important, like safety of the public, then healthcare, hospitals, then culture and education. Example, the government, they should give a proper education to all the public. Then street lighting, why they are speaking about the street lighting, it can able to provide safety to the people when they walk on the road. Then another one sector is energy and efficiency. The government, they should give proper electrical energy to the public. So earlier days, the electricity, before the modernization of the electricity, there is no interaction between the customers and the producers. But now we are having an interaction between the producers. Like I can able to interact with the electricity grid. That is called as smart grid. Then smart metering. Normally we will speak about what is smart metering in the upcoming slides. Then renewable and microgrids, real-time management and control, and then gas distribution. Okay. So gas distribution, it is supplied by the government. Then water distribution, control and security, storm water and sewage. That is under the water and air. And homes. So when you are speaking about urban, the population is increasing in a faster way. So we need to give a smart buildings, smart homes, and we need to integrate the smart buildings and the smart homes to the smart grid. Then mobility and transportation. So the transportation is much important for the public to move from one place to other place, even from the resident place to the job place, right? So when we move from the resident place to the job place, we are having a different problems like transportation. Transportation is a major problem, so we should have a proper public transportation systems. Then when we go in a public transports or individual owned vehicles, we are having the problem of the traffic. So effectively the government should manage the traffic. And nowadays, because of the CO2 emissions, right? So normally the government, they are asking the public to move from the oil vehicles to the like petrol and diesel. Instead of petrol and diesel, they are asking us to go to the electric vehicles, right? So electric vehicle charging stations, it is much important, especially internally. If you are traveling inside an industry, the industry, if you are going from office, moving from your office to the manufacturing unit, that time we can able to use more electric vehicles. So we need to have an electric vehicle charging station also. So these are the different sectors, these are the different elements. These elements are to be connected to the public, to the government, and to the business community. So how we can able to connect? We can able to connect through the communication technologies. So ICT technologies, they are integrating these all together and they are connecting these three stakeholders. So here, if you look, I am going to speak about generally about the public services and energy and efficiency. So in the public services, already I told you, we need to concentrate more on the street lighting. The street lighting, what it can do. Example, smart street lighting. Previously, we don't have street lighting. So if someone come, manually they come and switch on the street lights. Then the next day, maybe around 6 or 7, they come and switch it off. That is the earlier days we used to have the street lighting. But nowadays we are having a smart street lightings. So the what smart street lightings they are doing? They are doing a intelligent management. Okay, they can able to do the cost savings. Right? They can do the energy savings. If you look what the smart street lighting it can do, if you see the smart street lighting, it can able to control the light intensity. That is depend on the movement of people or vehicle. Even in some places in midnights, there is no movement of the people or there is no movement of the vehicle, then there is no need of a light intensity. They keep a light intensity in a smaller level. So depend on the movement of intensity. Is the brightness, the smart street lighting. Then example, if you are having 100 street lights, smart street lights, it is very easy for us where there is a fault. Like if there is a fault at the street light number 48, we can able to control it from the room itself. So fault control, we can able to do it from the control room. That is an advantages of the smart street lighting. Then additional sensor, air and noise pollution. Because we need to measure, yes, it is an urban city, it is necessary for us to measure the air and the noise pollution. That can also we can do with the smart street lighting. We can add extra sensors to the smart street lighting post that can able to detect the air and noise pollution. Additionally, even we can able to install cameras to monitor the traffic also. These are the different advantages we can do with the help of the smart street lighting. Data that is to be connected through the city to the people. So already we know the smart street lights, it is used in the streets. We can able to use it in the parks also, and also we can able to help the energy to move the people and the goods, right? Then heating and cooling, because normally we have two seasons, like we have a 4 seasons in Asia, but if you look other European and African countries, they are having majorly only two climates. One is a hot climate, another one is a very cold climate. So the climate here it is very extreme. Like if you take US or if you take Europe, the cooling is very high. In that time, they need to have a heating. So that heating can be also need energy in the indoor environment. So it is very necessary to produce renewable energy, because they made an agreement in Paris. All the developing and the developed countries they agreed to reduce the greenhouse gas emissions before the end of 2030. So all the countries they are moving to the renewable energy, especially when it comes to the urban community. When you do renewable energy with the smart buildings. And also the next one, mobility and transportation. Transport already it is much important from the home to the house, going from the home to the office, or going from the home to the college. Okay, so we need the transportation. So nowadays the mobility and the transportation sectors it is majorly improved in the airports. Example, they developed different types of transportation facilities in different airports. I given an example. Muscat city, it is in this UAE, United Arab Emirates. They have developed a city. In that city, the transportation they did it automatic. So there is no drivers. You can move from one place to another place. Example, from one train station to the another train station, or one airport to the other railway stations. Then King Abdullah Economic City, they developed it in Saudi Arabia. Then Changi International Airport, they did a lot of mobility and the transportation facilities in Singapore. Then New York, they developed another new international terminal at the John F. Kennedy Airport. They did the facilities in the airport also. Then San Francisco, they also developed another terminal. In the terminal, they developed this additional smart mobility and the transportation facilities. I given an example of the video about the Mustard City, how they are doing the movement of the people from one place to other place automatically without involving any human. I think the video is, you can check the video later. If you in the smart transportation, it is necessary we should have a smart parking meters. Then public transit management. Example, if I am moving from one terminal to the other terminal, then I need to have the transportation. So public transit management we need to have. Small parking locators. Example, when I'm entering into the airport, it is very difficult for me to find where there is free. So information. So we can use a vehicle information into communication systems or a GPS tracking. Then advanced cruise assist highway systems, contactless smart transit passes. Like we are using the online checking, so we are not communicating with any human. Just we can able to scan and we can do the online checking. Fixed road sensors, like you have a four roads they are joining in a junction, so we cannot able to say always the four roads they are busy. Sometimes maybe one or two roads they may be busy, so we need to track where there is more vehicles. So based on that we need to do the traffic management. So I told you already, they are using in some different airports the drivers for the movement of the people from one to the other terminal. Then the other one important sector the government is concentrating is on water and environment. So the quality of the water, and every time we need to do the forecasting, because when we do the forecasting we can able to avoid the drought and the flooding. Then smart buildings and homes, especially when we do the new buildings, it is necessary to speak about the green buildings. Residential load, that is an important. Previously we don't use more home technologies. Nowadays everyone is using the air conditioner, washing machines, dishwasher, ovens. So the residential load, it is the major one. It is consuming more energy from the power producers. So now if you look, we need to concentrate on this all, and we should combine this through the information communication technologies. So if we giving this all through the information communication technologies in a city, then the city it is called as a smart city. So here we did some estimation, like we have the annual electricity bill. So the annual electricity bill, it shows that the amount paid in USD, it is around 2,700, right? 2,700 US dollars. So we can able to do the load estimation, like how much time I'm using the how much time I'm using the washing machine, how much time I'm charging the plug-in hybrid electric vehicles, how much time I am using the dishwasher. So we can able to do the load estimation in a residential houses, so that based on that we can able to reduce, or we can able to implement the renewable energy in the building. So smart home demo. Then cultural education. So even now we can able to see there is a lot of problem, because many of the school children they are not able to access the internet, because we have a lot of digital resources. It can connect, we can able to connect with that, but we need an internet. So the government they should take a responsibility to give a high speed internet. Okay. Then cultural resources. If you see the tourism sector, it can develop even if we have extraordinary tourist places, but the outsiders they don't know about it. So the outsiders they can able to know only when we can able to represent our cultural resources in a online platform. That way we can able to develop the business also, because normally if you take around 7% of the GDP in every country is coming from the tourist sector. So ICT, it is connect peoples and the places in the urban environment. Example, a simple example, already I told you we are connecting. Example, I can do the recharge for the electricity through the online. Even I can purchase anything through the online. Even I can able to give a complaint to the electricity board. I have a problem in my house. These all it is done by the information and communication technologies. Example, I given an example, GPS enabled school buses. So the parents they able to monitor where their kids school bus it is now by using their smartphone. Okay, data and communication is very important. If you see what are the different existing methodologies in IoT communications, radio frequency identification, we can use the sensor nodes, gateways, cloud management, NFC, complex event processing, SCADA systems. Where the SCADA systems majorly used, because I'm going to speak more about the SCADA systems. SCADA systems, it is majorly used in the process industries like oil, gas delivery, water delivery, electricity delivery places. Then we have the other one communication technology, ZigBee, then information and discovery services. So we know what is a cloud. Cloud, we can able to access the data. We can able to access the apps also. Mobile communication and devices now we are using, and then big data and data management. So data information, it is much important to analyze everything. Even if I have a data of a weather for the last 40 years, I can say when the flood it will happen, when the drought it will happen. Like so, big data and data management. That is a doing a lot of present research. Then we have a different platforms and applications. So all over the world, we are having a different standards. Like if you take, we know the standards about ISO, IEEE. Like when we are developing a smart city, we need to follow different standards. Each country they have their own standards. Some of them they are in the international level. So if you see, we have IEC system committee for smart cities and communities. Then British, they have a British Standards Institute Smart City Framework. Then Germany, they have a German standardization roadmap smart city. Then ANSI network on smart and sustainable cities. Then we have a ISO sustainable development in communities. I given some. We have another 6 or 7 smart city standards and the initiatives. Here I given some projects which is happening in across the world. So in Austria they have the Vienna, New York, Amsterdam. So all over the world they are doing the smart city projects. When we look India they are doing around 100 smart city projects. Given on a website, you can go through this website. This website it can able to give information about what are the different smart city projects going in India. So around 100 proposals I told you, 100 around smart city projects going in India. So these 100 projects, it is going to impact around 99 million population in the urban cities like Kochi, Chennai, Calcutta, Mumbai, Delhi, Chandigarh, like that. The total cost of the project, if you see, it is around 200,000 crores. Okay, this is the smart city projects which is going in India. You can able to go through the link so that you can get more information about the smart city projects. Then some information about what are the different projects going. If you see here, they specify about animal carcasses at India. Okay, it is a one smart city project. Then they are asking to give a proposal for internet bandwidth connectivity in Faridabad city under smart city mission. So like that, you can able to see what are different smart city projects is going in India by using this link. So I just explained about you what is the smart cities. Now, how we can able to use smart grid in the smart cities. If you look, the smart grid. Earlier days, already I told you there is no interaction between the grid and the public. The customers they cannot able to interact with the grid. Normally, what I can do, if there is any fault in my house, if there is any fault in the pole, I need to go to the electricity board, then I need to make a complaint. So they will take some time to come and rectify the problem. But in the modern days, the grid it is become as a smart grid. Earlier days we know, like I can show you a picture. So this is the single line diagram of the power systems. So if you look, the generator power, it is from the generation station, it reaches the consumers. In between, the generated power, it is stepped up to higher voltages, then again it is stepped down to reduce the losses. Finally, it is given to the consumers. The consumer may be a industrial consumer or maybe a residential consumer, right? So earlier days, only the power flow, the energy flow, always we concentrate more on the energy flow, whether the power production it is improper, the transmission distribution system is working properly or not, the substation is working, and the load is connected. This is the energy flow. We give more importance to the energy flow. We don't give importance to the information flow. But the modern electricity systems, it gives more importance to the information flow also, because if there is any problem in a substation, that should be communicated to the other places. If there is any problem in the generation unit like power line, that information also should be communicated to the power system controllers and the other consumers also. So the energy and information systems, it should work together to produce energy properly to the consumers. When we look earlier days, the importance it is given more to the energy flow, but nowadays the information flow, it is having more importance in the energy sector. And is become into the smart grids, because there is a lot of blackouts happen. I'm just giving a picture about northeast blackout. It is 1965 happened and affected around 20 million people in New York, New Jersey, and Ontario. Then energy crisis, because the Arab oil, they got a problem in 73 and 74. Next to the coal, majorly we are producing energy by using the oil. Oil is the major sector which is giving the energy. The next one is we are having the coal. So the Arab oil embargo at that time, the electricity was increased. Then Western crisis happened at 2000 to 2001. That is also affected 1.5 million customers. Here, information, the Eastern Europe regions, Latin America, Middle East, and Asia Pacific region. So here, example, if you look into the Western countries, they are using mostly. Some of the countries they are using the nuclear power plants. Some of the countries they are using renewable power plants. Majorly, if you take Asia, it is dependent on the coal and the hydro power plant. If you take Middle East they are dependent on the oil, and Africa they are dependent on the coal power plant. If you take Southern Africa, they are depending on the coal, and North Africa they are depending on the hydro power plant because they have the Nile over there. So India, if you look, India and China, they are with a huge population in the world. They are consuming more energy. Next to India and China, Pakistan and Bangladesh, they are consuming more energy. So this tabulation, it can able to give how much people they are benefited by using the present electrical power generation. So energy flow information. So it is very much necessary for us to make a man-machine interface and a database. So here we are seeing about the primary analysis and the secondary analysis. Primary analysis, we can say the primary analysis is the energy flow. Secondary analysis is the information flow. These all data, it is stored in the database. So the man-machine interface, we can enter the database. We can able to see where there is a fault. Okay, what is the generation? What is the load consumptions? Normally, we know the power production, it is depend on the demand. So always the power production, it should satisfy the demand. So normally we do the load estimations. The load estimations we predict for a month, we predict for a year. So based on that, they generate the power. The generation power, that is not only depend on the load, it can depend on the weather condition also. Example, if the climate is very hot, we used to have air conditioners under the fan, so that will increase the load. At the same time, festivals, the festival time, people, we all stay together. So when we are in the family, if they are all in the home, then automatically the load demand will be also increased. So we monitor different parameters. We monitor like what is the load, what is the weather condition, whether there is any festival time, So we consider this all, then the power plants they produce the electricity. So if you see power system states, it is with the different sectors like economy, environment, quality, security. So when we are doing a production of the power production or the power system state should be inside with this. Like we should not make the power system to fail from the normal state. Okay, because we have a different states. Normal state means all the contingencies are running properly, there is no fault in anywhere in the system. Then we have alert systems disrupted, so when we are getting an alert we can able to rectify the fault and we can bring the system to the normal operation. The same way, if we the system it becomes to the disrupted, again we need to bring the system to the normal. But when there is a fault like a network splitting or a restoration, then we need to restart the system from the starting onwards. So when we are generating the power, the generated power it should not generated with a high cost, because the government, even we know, they are giving the electricity in subsidy, right? We are getting some benefits. Example, if the unit is for 1 unit, if it is 10 rupees, the government is paying 5 rupees, and the remaining 5 rupees only they are charging us. So the generation of power it should not cost more. Then the security, you heard about the security, there should not be any threat or theft. Okay, cyber security threats we say, and then we can say the theft, like many industries always they do that, right? Then the quality, so PQ we need to maintain in the power. Then environmental, because when we look about the environmental, we know already in India we are using more the coal power plants, and we are using more the hydro power plants. So normally we know when we are using a coal, it is emitting the carbon gases. When we are using the hydro, we are occupying a huge land. Okay, when you are doing hydro power plant, we are vacating a huge population, we are using a huge land that can able to also affect the biodiversity. So we need to operate the systems within these four. That is called as the power system states. So already we have a grid. That grid it is upgraded into a smarter way. Then it is called as the smart grid. So in the smart grid, what we are doing is we are using an information technologies. That information technologies they are helping the electricity to travel from the power plants to the consumers. And this smart grid, what it is doing, it can able to allow the public to interact with the grid. Like example, if I have a problem in my house in the electricity, or if I have a problem in the pole, then I can able to communicate with the grid. I can able to communicate with them through the voice response systems, right? Or customer care centers, I can able to say the problem. Nowadays, in many countries they are using the smart meters. We will Hello. Okay. Okay, I'm continuing. And improved technologies that of the SCADA system. By sitting in able to monitor infrastructure. Grid connected to the grid, it is up to the through the substations, commercial customer interacting power. So the generated power through solar and wind, it is connected to the grid. At the same time, we are generating power from the other power plants also, right? So this is supplying to the grid. From the grid, the power, it is supplied to the substation. Through the substation, it is supplied to the industrial, commercial and residential customers. Here we have a transmission control center, distribution control centers. So from the DCS or SCADA, we can use to monitor the distribution system. Grid system, the additional and electric, they need the charge. Then you have battery storage, other extra facilities also. So when we have the when we see the difference about the conventional and the smart grid, conventional grid, it is electromechanical, smart grid, it is digital. Here we have one-way communication, centralized generation, then we have less sensors, manual monitoring, manual restoration, right? There is a lot of failures and blackouts, limited control and few customer choices. But when we go to the smart grid, we have the digital communication, two-way communication that already I told you, the customer can interact with the grid. Then distributed generation, already everyone distributed generation means we can able to bring solar or wind. Okay, that is called as the distributed generation. Then we are keeping the sensors throughout the grid, so we can able to monitor, self-monitoring, self-healing, and then it can able to adapt for the islanding situations. Then many customer choice, pervasive control. So when we are doing this smart grid, we are having a different problems like economic competitiveness, because we need to generate the jobs, okay, and the technology regionalization. We need to divide the country into into many different zones. Through the zones, we can able to monitor. Then policy and legislative drivers. Example, we have always the electricity regulation authority. That the electricity regulation authority, they are the major people fixing the charges for the electricity, right? And the smart grid options, because many countries, they are not allowing the individual power producers to produce electricity to supply them to the grid. I can able to generate electricity, but I can able to use it for my house, or I can able to use it for my industry. I cannot able to supply it to the grid. But countries like developed and developing countries, they allowed the individual power producers to supply to the grid. Then energy reliability and security, we need to reduce the labor cost and the non-labor cost. When we go to the smart grid, we can able to reduce it. Then theft and fraud can be also uh, reduced by using the smart grid. Energy management, it will be effective in the smart grid. Then customer empowerment, and then environmental sustainability. Because when we use the renewable and the DG, then
Sir,
automatically the usage of, yes,
sir,
yes, madam.
sir, we are not able to see your slides, sir. It is not visible in the screen.
Okay.
Can you please check, sir? No, sir.
Now, is it fine now?
Ah, yes, sir, it is fine.
Okay. Where you are not able to see the slides?
From the last slide, sir. I mean, 32nd slide, I think.
This one is this one. We have seen this.
Ah, yes, sir. This and all we have seen. This is the starting one, right?
Yeah. Okay. Actually, can I start from here? Okay. We have five major groups. These five major groups,
Ah, yes.
they need to be involved in the smart grid. One is the policy and legislative drivers. So people those are fixing the price of the electricity, and the people those who are doing the smart grid options. Then the next one is economic competitiveness. Like we need to develop green jobs. Like when we are integrating the distributed generation into the grid, we can able to generate the different job opportunities, and we can able to create a region-wise control. Then energy reliability and security, we can able to reduce the labor non-labor cost. When the system it becomes as a smart grid, when we are modernizing the grid, automatically we can able to reduce because already we know we have the self-healing, self-identification. So in the case, it's not necessary manual, manual person to rectify the fault because we are using different sensors. Even we can able to predetermine whether there is any fault is going to happen. Reliability, theft and fraud, loss energy management. This can be also achieved through the smart grid. Customer empowerment, because if we are using a interaction systems between the customer and the grid, then automatically we will have the satisfaction level as high. Then environmental sustainability. When we integrate the renewable energy resources into the grid, automatically we can able to reduce the usage of the coal and the hydro. We also automatically able to save the environment also. So here we can able to see the benefits of the smart grid. The major benefits of the smart grid. If we start from the operational efficiency, we can bring the distributed generation, integrate distributed generation. So example, if there is a power produced at one place, example, if we have a power plant at Neyveli, the power generator, it can able to be supplied to the other end. Example, countries those who are having less power plants, example, if you're taking my place where I'm staying now, here we have only one coal power plant. That one coal power is supplied to the entire. But countries like our places where we have more power plants, they are having more than huge number of power plants. This huge number of power plants, they are located at different places because we have some at the some at wind power plants at Pollachi and other places. We have coal power plant at Neyveli and other places. We have the hydro power plants at Metu. Like we have a different power plants at different places, different regions. Okay, so these are all connected to the national grid through the but if I'm having a solar power plant near to my place, or if I'm having my own solar power plant, I can able to supply to my smaller community. Maybe I can take a smaller village, I can generate the power and I can able to distribute it to them, right? So integrate distributed generation, then optimize network design, remote monitoring and diagnostics. It is not necessary to go to the place and to rectify the fault. We can able to sit from the control room. We can able to locate a fault. Then improve asset and resource utilization, because when we are doing everything automatically, then there is no need of vehicle to go to the location, then there is no need of a labor to go to the location. Reduce the cost. Energy efficiency, that we know, we are improving the energy efficiency. Then green agenda, because we need to eliminate the greenhouse gases. Then integrating the renewable energy resources. Then wide adoption of electric vehicles. The electric vehicles we can able to use in different places. Like we can able to use in the institutions, we can able to use it in the industries. Already I told you, we can able to use it in the public government office also. Like customer satisfaction, already we know we can able to improve the power quality, we can able to reduce the energy losses so that the energy cost it can be reduced. Okay, and improve communications with the utility. These are all different advantages we can able to get when we are using the smart grid. So 7 goals in the smart grid: the consumer participation. We need to accommodate generation and storage points, new product services and markets, providing power quality, resilient against physical and cyber attack, self-healing. These are all different goals when using the smart grid. Then here I given a comparison the grid, today's grid and the modern grid. And then if you look smart grid technology span of the entire electrical grid, here we have different sectors: generation unit, transmission, distribution, industrial, commercial and residential. So here we are using different wide area monitoring, production and control method, and then automations. So different automation techniques, different communication technologies we are using in the smart grid. Able to go through these slides in detail, you can get some more information. So smart grid technology landscape, if you see, we are having different functionalities and capabilities. If you look, some of the functionalities and capabilities, they are already developed a lot in the sector. Some of them, they are now trending. So when we are speaking about the smart grid, we need to control the power systems. So controlling the power systems from the generation unit to the distribution place, we are normally using the SCADA systems. The SCADA systems, it use different remote monitoring. We have a master station. The master station is able to human machine interface we have. The human machine interface, it can able to communicate through the communication links to the remote terminal units. The remote terminal units, it can able to monitor the position of the actuator, the level of the meter, the level of the accumulator, and they can able to control the PLC. So these all information through the remote terminal units, it is transferred to the SCADA master station. Through the SCADA master stations, we can able to give commands to the RT. This is the SCADA system. This SCADA systems, it is also a one of the part of the smart grid. So we can able to control effectively the generation, transmission, and distribution units. So here the SCADA systems data flow architecture. We have a different parameters like what is the analog output, control output, pulse accumulator, analog input, status input. All we can able to get into RTU. We can able to monitor this all information through the RTU. The RTU, it can able to send the information to the master station. Through the master station, we can able to give commands to the RTU. We can say we need to trip, or we need to close, or we need to open. So, and the next one parameter in the smart grid is meters. So already I'm just showing a meter. You have different meters. You see mechanical meters, then electronics meters. So these mechanical and electronics meters, they need the manual metering. But in meters, it is not need any manual metering. It can able to say what is the electricity you consumed in a day, in a month. Okay, even if there is any fault in the home, it can able to also automatically inform to the grid. That way we can able to reduce the human intervention. Okay, so when we go to the smart metering, we can do the remote recording, real-time information we can see, remote controlling, and we can see the quality controlling. We can able to give a feedback, remote find the update. We can able to the smart meter. So here I give information about the existing meters. So the existing meters, they have the manual collection of data, and then we do the manual billing. But smart meters, they have the communication interface protocol, and they use the gateway. Through the gateway, they can able to store the power consumption in a database. So if you see here, we are having a LAN, then collectors, then we have wide area network, then it is stored in the database. When we store the information, we can do the outage management also. Like I can able to monitor by accessing the database. Okay, there is a fault. So the outage management also we can able to do through the smart grid. Then this is the electric charging station, because electric vehicle is also one of the important terminology in the smart grid, because we need to install electric charging stations. Like how we have the fuel stations nowadays, a lot of fuel stations. The same way we need to bring the electric charging stations also. So if I am traveling from one place to the other place, in between time how we are fueling the car, the same way we can able to charge the electric vehicles also. This is the picture how we can able to do the electric charging. Then outage management. Normally we know outage management. Example, if there is any fault in my house in the electricity, I need to communicate with the electricity board so that they can able to come and they rectify it. But here is OEM systems. The OEM systems, already I told you, when we are integrating the ICT technologies in the smart grid, automatically they can able to detect where there is a fault. So when there is a fault, immediately they can able to rectify the fault without having an information from the customer. So when we are going for outage management systems, the outage management systems, it can able to do all the informations. They can able to restore the network model after an outage. They can able to do the tracking and displaying the outages also. So we can able to collect, organize, display data from the field, customers, field crews, SCADA and smart meters. They are all management systems. We can able to do the predictions. We can able to do the locations where we have a fault. Then that information it can be given to the database so that restoration times it can be informed to the customers. Your fault will be rectified within 10 minutes or 30 minutes or within 1 hour. So the management of crews, they can assist in the restoration, and we can able to do the calculation how many crew we need to go and rectify the fault. These all we can able to achieve through the smart grid systems. So information management we can do, timely data, accurate data, where there is a fault happened, what time the fault happened, what time the fault is rectified, right? And then work management. So how many people we need to solve the problem, okay, so that we can able to improve the employee productivity also, faster and more effective new employee training. Because if they have a database of different types of fault, what are the fault it is happening normally in this time of this time of rain season. So it is very easy for us to give training also effectively. Then disaster management we can able to do. Then enterprise management. This all we can able to do through the outage management services. Then we are using IoT also in the energy sectors. So IoT, that is using different technologies in the electricity generation in the smart grid. So we have a personal area network, local area network, NAI network, metropolitan network, and then wide area network. So we are able to control the power flow from the generation to the consumers. So here just I specify what are the different man to machine technologies which we are using. So here I just specified the information of IoT technologies behind the meter. If you look, we have the meter. The meter it can able to do the display. The meter it can able to send the information about the current price through the Ethernet to the tablet. Okay. So IoT is also involved in the smart grid. Here I specified how we can use the workforce through the IoT in the picture. And then just I want to show you a real-time model. This is the real-time model we developed in a small village for the school and the staff housing. I enclosed the video. Finally, we found that per year we need a total kilowatt hour of 10,000. We just developed now a real-time model of renewable energy systems for the school and staff housing. And now we received some grant to develop the model and extend it to the clinic and centers and to the Kotla. Kotla, it is like a the office for them, the municipality office we can say. I enclosed a video also what we developed in a primary school. You can go through the video so that it will give some clear information. First references which I specify, it is a book. It can able to give more information for you the smart grid and about the smart city IoT technology. That's all about my presentations. If you have any queries, we can interact. Thank you for your coordination.
Thank you, sir. Thank you, sir. If you have any queries, listeners, you can post your queries in your Q&A session. Okay, sir. I hope there is.
There's no question and answers. I'm sending the slides to the coordinator so that she can able to distribute it to you. Maybe if you have any questions, you can able to communicate through my email ID and through my WhatsApp number.
Yeah, sir. Sure, sir. So thank you for your presentation, sir. Thank you for your kind accepting the invitation and giving a very good lecture on smart grid. I hope our students will have got some knowledge about smart grid and about smart meters and SCADA everything. So thank you very much, sir. Thank you for your
Thank
session.
you, thank you, thank you very
Thank,
much, madam. Thank you,
thank you.
thank you. Good day.